Okay. Well, hello everyone, and thanks for coming to our session and joining us from wherever you are in the world. We're so happy to be here today with the Women Who Code community and to talk about how to get started and also why everyone can get started with Android using Jetpack Compose.
So I hear this a lot, that it's really hard to learn or to transition into mobile. And it's actually gotten a lot harder over the last couple of years as the platform becomes more complicated and complex. There are a lot of reasons for this, but some of the main ones that Alex and I came up with were that programming for mobile is a totally different paradigm and has different architectures and patterns than some of the other stacks. Deployment for your changes on mobile is really different than deploying changes to a website. And you're also developing for a really small device with a very small little operating system that you've probably never worked with before for any of your other projects. In addition, for most people, it means learning a new language. And sometimes in the case of Android, it might mean learning 2 new languages. And then for Android specifically, you're dealing with a huge number of devices that can vary greatly in performance and screen size. And because Android is open source, each can have a slightly different operating system running. And so you have to learn how to deal with those quirks and weirdness around that. We also have to worry about things like life cycles, fragments and activities, and the difference between all of these at the same time.
So the deck is stacked for you when trying to transition to Android development. Jetpack Compose will make it easier to get started with Android, and during our talk, we'll show you how.
So we'll get started by introducing ourselves and explaining to you what kind of backgrounds we bring to the table when we're talking about Jetpack Compose. My name is Sierra, and I'm a longtime Android engineer, but a first-time Jetpack Compose engineer. Android was actually my first role in tech, and I liked it so much that I decided to stick around this whole time. And so I bring that perspective of traditional Android development. I've gone through a lot of changes in Android over the years. I've gone from model view controller, MVC, to model view view model, MVVM. I've worked on projects that have multiple activities, and I've worked on projects that have multiple fragments. And also, midway in my career, I had to transition from Java to Kotlin. And now I'm going from the imperative paradigm to declarative. For those of you who might know a little bit about Android development, I'm a huge fan of XML and building custom views. And so learning this new framework was a really big mental shift for me as we move away from those.
And my name is Alex. I'm a longtime front-end engineer and short-time Android engineer. I've worked with React and currently worked with Shopify and vanilla JavaScript. I'm coming to Android from a web perspective and learning Jetpack Compose as well. I face different challenges in learning Compose, given that my frame of reference for Android development isn't as large. So we're both learning Jetpack Compose and bringing really different experiences and backgrounds. And over the next 30 minutes, we'll bridge these backgrounds to give a holistic perspective of getting started with Jetpack Compose.
So we've mentioned a couple of high-level features of Jetpack Compose in our introductions, but let's dive into some of the specifics and backgrounds of this new framework.
Cool. So Jetpack Compose is Android's modern toolkit for building native UIs. It allows you to build better apps faster. At a high level, how does it allow us to do that? So first, you can do more with less code. It has even less boilerplate than traditional Android. So you're able to avoid entire classes and layout files. So your code is simpler and easier to read and maintain. With less code, it also means you can potentially get started faster and contribute quicker. And finally, less code equals less bugs. Bugs can't grow from white space. Second, it's more intuitive and than traditional Android. You just describe your UI and Compose takes care of the rest. As app state changes, your UI automatically updates. It also allows you to accelerate development. It's compatible with all your existing code, so you can adopt it when and where you want. Being able to iterate fast with live previews and full Android Studio support makes something that is often challenging into a delightful experience. And last but not least, Jetpack Compose is powerful. You can create beautiful apps with direct access to Android's platform APIs and built-in support for material design, theming, animations, and more.
let's dive a little bit deeper into what does Modern Native Toolkit mean? So first, it's a declarative framework built by Google specifically for the Android operating system. So we talked a little bit about how I'm switching from an imperative framework to a declarative framework. Historically, our Android UI framework was an imperative framework. The formal definition of imperative programming is a paradigm of using statements and commands to change a program state. It involves having a separate model of the application's UI. A declarative design focuses on the how of the app rather than the what. The example in Android is that we traditionally use XML layouts to create our views. We design the widgets and components, which are then rendered for the user to see and interact with. An Android view hierarchy has been represented as a tree of UI widgets. And as the state of the app changes because of things like user interactions or data updates, the UI hierarchy needs to be updated to display the current data. We did this by calling things like setProperty. Manipulating views manually increases the likelihood of errors. Now we think about our declarative framework in describing our UI in an intuitive way. Formally, imperative programming is a paradigm that expresses the logic of computation without describing its control flow. In contrast to imperative programming, declarative programming, we tell our application what it should do and look like in different states, and then the app itself handles moving between those states. This pattern allows developers to design the user interface based on the data received. This, on the other hand, focuses on the what of the app. And this design paradigm also makes use of one programming language to create the entire app.
Jetpack Compose uses Kotlin all the time. So it's all Kotlin all the time. And because we don't have to rely on XML to create our layouts, our apps are able to be just as dynamic as any other Kotlin code. For example, suppose we want to build a UI that greets a list of users. With Compose, all we would need to do is create a for loop and our list of names and insert the name as a parameter in the desired text composable to generate a greeting for each user. Although this is a simple example, composable functions can be quite sophisticated. You can use if statements to decide if you want to show a particular UI element, use loops, and call helper functions, because you have the full flexibility of the underlying language. This power and flexibility is one of the key advantages of Jetpack Compose.
And finally, it is in fact so modern that Jetpack Compose is still in beta, but a stable version of Jetpack Compose 1.0 is set to be officially released in July. And so Android joins the future of programming because we've seen this shift from imperative frameworks to declarative paradigms across mobile development. iOS development is moving towards Swift UI, a native declarative UI framework written in Swift for iOS apps. And we also have things like Flutter, a cross-platform UI framework for developing Android and iOS at the same time.
My first web framework was React, and it's also a declarative JavaScript framework. Ionic is another declarative framework for building apps with JavaScript. So this trend is not just in mobile, it's in web as well. Having an understanding of the declarative paradigm is a transferable skill. Knowing a little bit about React or Swift UI or any other declarative framework is going to make it easier to get started learning Jetpack Compose. Similarly, knowing a little bit about Jetpack Compose is going to make it easier to get started with the others.
So now let's see it in action. I always tell everyone who wants to get started with Android that a really good starting place is to use the basics and build an app that displays a list of data and also has a view to display some details. That's actually the first project that Alex and I worked on together when she was just getting started. And so learning Jetpack Compose is a new framework for me and Alex to both learn. And so a good place to start is going back to the basics and building an app that displays a list of data and shows some details. And instead of building the classic Hello World app, we'll stay on theme with our Jetpack Compose libraries and build a Hello Mars app.
Each declarative framework has their own way of defining or creating a piece of UI. For React, it's a component, and for Jetpack Compose, it's a composable. Think of a composable as one of the building blocks of your screen. A composable is a function that uses the @composable notation to let Kotlin know that you are creating UI components. It also tells Compose to add support to the function for updating and maintaining your UI over time. It's a pure function, which means that given the same inputs, it will produce the same outputs. It has no return value, and it emits your UI instead of returning a view. Since composables are functions, you can pass in parameters, and you can call other composable functions from within your composable. To the right, we have a simple example of a greeting composable that emits the Hello Mars text to a screen. Looking from a traditional Android lens, it would be a lot of work to even display this Hello Mars. This single composable replaces an entire XML file and layout that would need to be inflated in a fragment or activity. So now let's look at our detail screen to get a feel for thinking in Compose and deciding how we could structure our composable functions to create a screen. We can look at this entire screen as a composable, as well as the image and the 3 lines of text could be composables as well. With Compose, you can make your UI as nested as your heart desires. The one caveat is that using a lot of composables and nesting in your screen will affect the readability of your code. So you should use it wisely. Now let's jump into the actual code. Thinking back to linear layout from traditional Android development, it allowed you to lay out items on a screen with orientation, be it vertical or horizontal. Within Jetpack Compose, we have column and row. Column is like a linear layout with vertical orientation, and row is a linear layout with horizontal orientation. Both allow you to lay out composables on a screen very easily by allowing you to set the alignment and arrangement properties for items within them. Coming from a front-end background, it's very similar to Flexbox with being able to align and justify items along different axes. Box, on the other hand, is similar to frame layout. It helps you to display children relative to their parents' edges. By default, composables will stack in the top left along the z-axis. So wrapping composables in one of these layout elements will stop this stacking. Column, row, and box are the most basic building blocks that we can use to build complex layouts. And lists are made simpler with Compose as well. On our previous slide, we talked about column, and we used it to lay out our photo details composable. Now we'll use column as the building block of our photo list composable. When we look at the meat of this, we see that we're using Kotlin's for each index to loop through the contents of our list and place one photo item composable on the screen for each item in our list. This is an example of how we can use the underlying language features of Kotlin to quickly build UIs. We know column allows the item to flow vertically. However, we have more items than can fit the screen at once, so we need to add scroll behavior. To do this, we'll need to add a vertical scroll modifier. Row has a similar property for horizontal scrolling. Sierra will talk about modifiers next, so I won't go into detail, but for now, just know that this modifier adds the scroll behavior that we need. To do this, we'll need to add, using column or row while looping through a list of data can be expensive, especially if you have a long list of items to show or data that changes. This is because solutions like this render all of the items in the list at once.
If you've worked with Android for many moons like I have, this may remind you of the performance issues that we had when using the list view widget. This was solved in traditional Android development using a recycler view.
So what do we do in Compose to handle situations like this, you may be thinking? Never fear. Compose has lazy column and lazy row, which not only composes, which composes and lays out the items that are visible. As you scroll, new items are composed and old elements are disposed. Lazy column only lays out items which are visible on screen, similar to recycler view. Lazy column doesn't recycle its children like recycler view though. It emits new composables as you scroll through it, and it's still performant because emitting composables is relatively cheap compared to instantiating Android views. And its implementation is much simpler and more intuitive than setting up a recycler view. And recycler views, if you remember them, they were very exhausting and cumbersome. They required an adapter, view holder, and a layout to place it in. It was a lot to remember and required a lot of boilerplate. Now, if we look at our code, we see that we've replaced column with lazy column. Lazy column has scroll behavior built in, so we no longer need our vertical scroll modifier. And instead of using our for each function, we use the inline items function that takes in our list and lambda function to loop through and display our photo items.
So Alexx has given us a great foundation to start building out our UI using composables, but our app isn't the prettiest app in the solar system. So how do we start customizing our app in Jetpack Compose? Answer, we'll use modifiers. Alexx has already given us a sneak peek of modifiers when talking about implementing scroll behavior in a column composable, but let's look at some of the other things that modifiers can also do for us. Modifiers tell a UI element how to lay out, display, or behave within its parent layout. You can also say that they decorate or add behavior to UI elements. They can control things like the size of your element. You can use them to set the height and width, similar to using layout height and layout width in XML attributes. And you can also use them to set the mins and maxes for those height and width. You can also use modifiers to control the shape and color of your UI and set backgrounds. So there's no need to create custom drawables and set those in XML. You can also use them to add padding and elevation. And if you worked with Android and ever tried to add elevation to a custom view with an interesting shape, you know that that was very difficult. And finally, you can use them to control things like scroll behavior and also add clickability to your views and set things like your on-focus listeners. So let's look a little deeper into how we are going to use these modifiers. Most composables take in a modifier as an argument of the composable function. It's a good practice to build your own reusable components to also include a modifier argument for ease of customization in the future. When we look at the image composable that we're using for both the details screen and our list, we see that the modifier is the third argument. We also see that there are two required arguments for our image composable: the painter, which is our image source, and the content description. Every, or at least most composables, have a mixture of required and optional arguments. The required arguments are going to be arguments that you need for that composable to make sense. For a text composable, this is going to be the text that you want to display with it. For an image composable, it's the image source. In a content view is one way that Jetpack Compose is encouraging developers to think about building accessible UIs. It turns out for composables that don't have a content description as an argument, the way to add those accessibility properties is through the semantics modifier. So it fits right in with our conversation with modifiers. The required arguments, along with those optional arguments, and then all the things that we've talked about that you can do with modifiers, are going to give you the ability to build out a UI with all the flexibility that we had with XML attributes and drawables and all the view properties. And so you will not be lacking customization. Different modifiers chain together to give you your final outcome. The order of the chain matters, and a different order might result in a different UI. We take our chained modifier and we pass that into our composable for our final result. So let's see it in action. We're going to take our app that Alexx has so kindly built out for us and theme it like our presentation. So let's look at the code. So first, we're going to add some modifiers to our lazy column. By default, these basic composables that Alexx talked to us about, like row and column, lazy column, are going to by default wrap around their contents. You can think of this as the XML attribute wrap content. We're going to add this fill max width modifier to our lazy column, which is similar to thinking about the layout, setting the layout width attribute to match parent in XML. Then we're going to make use of how easy it is to arrange our components in our column, like Alex mentioned earlier, and we're going to pass in an alignment of center horizontally. So now we have our column filling the screen and the contents are centered inside. Now we're going to jump and modify our image composable. We're going to pass in our required parameters for our painter as our image source and also add a meaningful content description. And then we're going to add some modifiers to make our app a little prettier. First, we want to add margins. Unfortunately, margins do not exist in Jetpack Compose. Instead, we have to take advantage of the ordering of our modifiers to use padding to act both as margins, which you can think of as space pushing away from your view, and as actual padding, which you can think of space pushing inside your view. So the first thing that we do to our image is add 8 pixels of padding. This will be applied to all sides of our image, but you can also use the padding modifier to specify a specific side or a specific orientation. While it's hard to see, our image now has padding. Next, we're going to clip our image into a circular shape. And so we use clip and pass in a circle shape from Jetpack Compose. This is super convenient because we didn't have to make our own drawable to make this happen. No XML shapes were involved. So now all of our images are circles, which is great. Yay. We want to give our image that green border that Alex and I used in our original intro slide. So the next thing that we're going to do is add a background. If we ran the app now, it wouldn't have changed at all. The reason for this is because when we apply that green background, it's going to be below our image, and the image is taking up the whole space that we have. So now it's time to use our padding modifier again, and this time we're going to use it to give us an actual padding effect and take this background and push in the image. And so we see that we're applying 12 pixels of padding again on all sides because we didn't specify a specific side to apply this on. So now we can see our green background, but what the heck happened to our image? It was a circle before. When you think about applying that clip modifier, it's not actually changing the shape of our image, but rather you're looking through a hole at your image. And so now that we've pushed our image inside our circle, it's obvious that it's still a square. But that's okay. We can easily fix this by clipping our image again, and we apply the circle modifier, apply the circle shape as our final modifier. And now our app looks great. So you may have noticed that our background magically changed, and we never talked about this while setting up modifiers. The background color is actually controlled by the theme of the app, and we can easily control this because our whole app is wrapped inside a theme composable. And that controls things like our background color and the primary and secondary colors that we use in our app. On the left-hand side, we see that we're setting our content, and we see that my theme composable, where we set dark theme equal to true. And inside of that composable, we have my app and our main screen. On the right-hand side, we can look at this theme, my theme composable, and we see that all it does is toggle between our dark color palette and our light color palette and pass that into our entire material themed app. This gives us one single place where we can control our color palettes and our theming really easily.
Right. So we built out our list view using the lazy column, and we built out the detail screen. So how are we going to pull these together and keep track of changes within our app? We can use state. One of the key features of Compose is that it's reactive, which is to say it automatically updates in response to state changes. In our example, we're going to use state to keep track of which view we should be showing. So state allows us to update the data within a composable using a unidirectional data flow. An event will happen within our UI, say a user clicks a button, or in the case of our app, an image, that triggers a change in state. And then those state changes are sent back down to emit that update to the UI. Just like within React, we use state for anything that will need to be updated over time. We'll use mutable state of to declare a state variable. This declaration gives a composable mutable memory, meaning that it can be rewritten. Items that are hard-coded or not dynamic get written to the UI tree once and are never updated. We'll use the remember keyword to use the same state within each recomposition of our composables. State does present challenges, though, when we need to update different composables all based on the same piece of state. We'll want to use state hoisting to lift the state to the parent composable and then send a copy of the state through the nested composables as an argument. It's a similar idea to using props within React. This process allows those nested composables to be stateless, which in turn makes them easier to test. So this is a snippet of code from our main screen composable. First, we see that we have 3 state variables, one for our list that comes from our view model, one for a Boolean we use to toggle when to show the photo details composable, and another that we use to remember our selected photo. Next, we see that we have our photo list composable and our photo details composable. Our photo details sits behind an if condition that uses our show details state variable. This means that when show details is toggled to true, our photo details will be emitted to our display, and otherwise it won't be added to our UI. Instead of declaring the show details and photo details state in our individual composables, we are declaring our state within the parent composable and passing them in to the nested composables. This is an example of state hoisting, and it allows our photo list and photo details composables to be stateless. Whenever state changes, Compose will reinvoke all the composables that depend on that state and update your UI. This process is called recomposition.
Okay, so what do you need to know about composables and recompositions? The first thing to note is that composable functions can execute in any order. This means that you can't guarantee one composable will run before another, and so each composable needs to be self-contained with access to the variables or state that it needs to render. This means that if you have 2 composables, say a top of screen composable and a bottom screen composable, and the top of screen composable set some global variable that you also need in the bottom screen composable, you can't guarantee that that value will be there, even though top of screen composable is called first. Extending on that, not only can composable functions execute in any order, composable functions can also run in parallel. So you can't even guarantee that they won't happen at the same time. Recomposition is also smart and optimistic. Recomposition starts whenever a composable thinks that a parameter of a composable might have changed. It means that optimistic means that it expects that recomposition to finish before the parameters change again. If a parameter does change before the recomposition finishes, Compose might cancel this recomposition and restart with a new parameter. It's also smart that it looks only to recompose composables that it thinks it's changed. And so you have to watch for this when thinking about side effects. And finally, composable functions might run quite frequently. In some cases, a composable function might run for every frame of a UI animation. If the function performs expensive operations like reading from device storage, it can cause the UI to lock up. We can avoid this by doing those expensive operations on a different thread, like the background thread, and then passing that data to the UI once it's ready to be rendered.
And now we have our final product, which is a list and a details view. We can click on an image and the details view animates up to show its contents.
It's also worth noting that we would not recommend using state to handle navigation in real life. While it was a really great example of how to declare and use state in our little app with only 2 screens, this would not be a scalable solution. And there is actually a Compose library, a Compose navigation library that makes handling navigation really easy. So wrapping up, we wanted to go over a few final reasons why we are so excited about Compose. The first reason is integration. Integration is a big one, and it can mean a lot of different things when it comes to Compose. The first thing is that while it's a great choice if you're starting a new project, you can also add it to your app to an app that you're already working on. You don't have to wait for a new project to get started with Compose. It can integrate and be added to projects you're already working on. Second, libraries. There are many libraries that we in the Android community know and love and use consistently. And moving from traditional Android to Compose does not mean moving away from those libraries into all new libraries. In this project, we used Retrofit to make our network calls, and we used Hilt for dependency injection. We also used a Compose version of the Coil library to handle our image loading. And finally, it can be integrated with architectures that we already use for mobile. This particular application was written using MVVM and the Android architecture view model. While we still have to see what the long-term best choice in architecture is when using Jetpack Compose, for now, we can use it with the things that we already know.
So the second reason that we love Compose is that it's all Kotlin all the time. We said this before, but we wanted to come back to it as we wrap up, because Compose can be used in a lot of different places, which means that Kotlin can be too. A central theme of our talk is that learning Compose is easier than learning traditional Android, but it also means that in the process, you're learning Compose for everything. You can use Compose to write desktop apps and web UIs, and it actually integrates with React. So if you're not interested in mobile, you can use Compose for the web and never have to learn Android.
And finally, we think it's a really great time to get started. Like we mentioned earlier, Jetpack Compose is brand new, and so we're all in this together, learning together. There's a lot of really great resources coming out every day and a community being built around it. And with that, we want to thank everyone for spending the last half an hour with us to learn about Compose. If you want to find Alexx or I after this conference, you can find us on Twitter @_Sierra O'Brien and @_Alexx Mitchell, or you can find a whole host of ways to get in touch with either of us on our websites, srobryan.github.io or alexmitchell.com. We also wanted to share the resources that we use to put together this presentation in case you want to dive deeper into Compose and get started. We really recommend the Google Learning Pathways and Google Developer Docs for Jetpack Compose. They have pathways that lead you through code labs that can get you started with all these different aspects. And they also have a lot of documentation to help you start thinking in Compose and using this new mental model. We also really like the Ray Wenderlich book, Jetpack Compose by Tutorials, that you can build an app from scratch using Jetpack Compose. You can also find our slides and the code for this example app online on my GitHub at github.com/CierraO'Brien/MargeRoverCompose. And with that, we have some time for questions.
Well, thank you so much, Sierra and Alexx. That was an amazing presentation. I didn't really see any questions in the chat, but does anyone have any questions now they'd like to ask? Okay, just a comment. I haven't done Android development in a couple of years. It's interesting to see what's changed.
It's changing fast.
Yeah.
Every year we have to learn something new.
A lot of people are giving shout outs and thanks for a great presentation.
Well, if anyone has any questions after the fact or think about it late at night and need to follow up, you can find both Alexx and I in the Women Who Code Mobile Slack, and Mackenzie posted a link to join that, and we would love to see more folks there.
So thanks again.
Yes.
This was amazing. Thanks everyone for coming.
Thanks.
Thank you.